Okay, this lab can be rather confusing, so let's walk through the first part of it where we build our program, and then I'll get you started on the part where you pick it up, and I'll let you complete it from there. So first of all, let's explain what you're looking at here. You're looking at a very simple CPU. Over here on the right, you're seeing some registers here, registers 00, 01, 02. These are just spaces that the CPU can hold stuff temporarily while it's doing calculations on them. It's got some special registers, including this one that we talked about this week, the program counter, that holds the value of the next instruction that should be executed. And it's got some others in here. I'm not going to bother to go through these right now. It's got something called a program stack, and I'm not going to get into the program stack. It's a little deeper than we need to get into here. Right here in the second pane here is a list of my programs. Right now I haven't written any programs, so there's nothing in there. We're going to write one in a moment. Over here on the left-hand side is RAM. Now this is where instructions are in RAM. Now RAM has actually two parts. There's a section of RAM that has where instructions are, and then there's a section of RAM that has where the data is. So for example, if you have an Excel program, there has to be a section that has the instructions themselves, and then a section that holds the data. And the two aren't mixed up. They can't be together. As a matter of fact, there's some technology that makes sure you can't perform instructions where data belongs, so that hackers can't use that technique. But anyway, that's a whole other discussion. We're going to show that in a little while. I can't right now because that button is grayed out at this point until I start creating a program. So down here we've got three tabs: program, instructions, and optimize or assemble. I'm not going to worry about this one. We're going to use the program and the instructions tab. First, let's start by naming a program. I'm just going to name the program by my first name, Roger, and the base address 100. You can really put anything in here that you want. I just use 100 sort of randomly, and I'm going to click add. And now we have that program here, right here. Okay, let's start by writing our program then. So I'm going to go over to the instructions right here, this instruction tab, and if I remember right, I wanted us to add 9 and 5, and I had a special way for us to do it. Okay, so let's begin doing that. The first thing we're going to do is add a new instruction, so let's click add new. Oh, by the way, we should show the data, show program data memory. So I'm going to click, let's close this for a moment. I'm going to click this show program data memory. This is where our data resides in this. Let me see if I can grab that and bring it down here. You can't see it, but my recording bar is in the way. There we go. This is my data here. Let me explain this, how this works a little bit. So 0000 in my data memory starts right here. Byte 0, so this is 0000. Byte 1, this would be 0001, 0002, 0003, 0004, 0005, 0006, 0007, and then right here indicates that 0008 is starting. So this one's 0008, 9, 10, 11, 12, 13, 14, 15. 16 starts here, 16, 17, 18, 19, 20, and so on. So when I say 32, for example, well, 32 starts right here, 32, 33, 34, 35, 36, 37, 38, 39, and so on. All right, so this is where data is going to reside. All right, now let's get back to our instructions. We're going to click add new, and we have different categories of instructions here: data transfer, arithmetic, control transfer, comparison, and so on. Well, right now we want the data transfer because the first thing we're going to do, I asked us to put a value of 9 into RAM space number 20. Where is 20, by the way? Well, this is 16, 17, 18, 19, 20. This B4 under the 16 before, that is space number 20. That's where our 9 is going to go. All right. So let's go ahead and do that. I said to use the STB, that's store a byte, and we're going to store the value 9 in RAM space. This is direct memory here, number 20. Now, if I wanted to put it into a register, I would put that down here and put it into a register. But I don't want to do that. I want to put it directly into memory space number 20. This is a literal value into direct memory. I'm going to put it directly into space number 20. I'll click New Instruction, and that will put it there. All right, so we're ready now to do the next instruction, and that was to store 5, the value 5, in RAM space 21. All right, so that's, if this is 16, 17, 18, 19, 20, 21, so we put 9 here and 5 here into these RAM locations. All right, now in order to do an operation on these, I need to put these, in order to add them together, I need those values from my data here to be in registers. So now I need to move those into registers. So I decided to move, or not move, but to load the value of the first one, location 20 here, into R01. So let's do that. We're going to load LDB 20, direct memory location 20, into register 01. There we go. We're going to load memory location 20 into register 01, just like that. Now we're going to load location 21, which is this B5 right here, this one. We're going to load that, 21, into register 2. Like that. Load memory location 20. By the way, this little number sign means a literal value. When it's just a number, it is memory location. When it's an R, it means the register. All right, so we're loading memory location 20 into register 1, memory location 21 from over here into register 2. All right, now we need to add them together. Well, we have an add under the arithmetic section here, and let's just take whatever is in 1 here and add it to, well, we need to use another register. We'll use register 3 here. Right now register 3 has 0 in it, so I'll just add 1 to 3. So that would make 9 in register 3. So I'm going to click add register 01 to register 3. So now whatever's in register 1 will be added to register 3. So now register 3 will have 9 in it at that point. Add register 1 to register 3. Now we'll add register 2 to register 3. So first we put the 9 into register 3, and then we added whatever is in register 2, which is the 5, which we got from memory space 21, into 3. So now 3 has the 9, and now we added 5 to it. Right? So it's 3 now has the value of 9 plus 5 in it. All right, finally, we're going to take whatever is in R3 and put it back into RAM. Right? We have to move it back into RAM. So we're going to go back to data transfer, and we're going to do the STB, and we're going to take the value of register 3, and we're going to put it in, I believe we put it into 16, is that right? No, we put it into 24, I'm sorry. Yeah, we put it into 24. So into memory location 24, which would be this B0 right here under 24. So we took R3, we put it back into RAM. All right, we're almost done, with one exception. We still have to halt the program, otherwise we'll get an error. So we're going to add a halt statement. I'll click New Instruction, and now it's ready to run. Let me close this, and we're ready to run this. So I want you to watch this yellow over here. What should happen is this B4 here under 16 should become a 9. The B5 should become a 5. And then the 24 should become 0E. Well, that's because 0E, E is hex for 14, 9 plus 5. And all of these are hexadecimal values. 9 is still 9 in hexadecimal. 5 is still 5 in hexadecimal. But 14 would be 0E in hexadecimal. So let's run our program. And here we go. Run and watch them. Oh, I see what I did wrong here. I had this sitting in halt. I need to put it up here and then run it. There we go. Let's try that again. So you can see it running here. 9, and then 5, and then 0E, and it's done. See, I have to put this where I want it to run from. So, sure enough, it put 9, and then put 5, and then 0E. Let's go back up here and run it again. I'm going to reset that. I'm going to reset this. I'm going to reset the program. And this time, let's go up here and then watch these registers as I run this program. So let's just watch these. And you'll see there's the 9, there's the 5, there's the 14. And then it puts the 14 back over here. Is that pretty cool or what? By the way, the program counter, let's reset this program again. Reset all 3 of these things. Put this back up here and run it, and you'll watch the program counter. It will count up where the next process or where the next instruction is, and you'll see that that correlates here to this number right here, the LADD number. You'll see that that this begins at 100 because I started, if you remember, I started at 100. The base number is, or my base memory location was 100, so it started at 100. So, but as far as it's concerned, it's calling 100 0, and then it's adding that many bytes as it goes forward. And so that 7 becomes the next PC, and then 14, and then 20, and then 26, and so on as it runs. Alright, so that is how a CPU works. Now, I said that we have a problem. What happens if R3 already had something in it? What happens if there was already a value here in R3? Well, I wouldn't get 14, right? As soon as I add R1 to 3, then it would have a value other than 9 in it. So we want to fix that problem. So how would we fix that problem? Well, let's see. We move that back up there. Let's see if we can. Well, let's just write a new instruction, then I will, insert. I need to insert below. That's what I need to do. So right here, before I start putting this in R3, I'm going to insert below, and I'm just going to put the value 0 into R3. There we go. I put 0 into R3. Now I know that R3 contains a 0 as soon as, before all this stuff starts up here. So now my program will work even if there was data already in my R3. See, right now I've got a 14 R3. Well, what happens if I ran it at that point, right? So that could be a problem. All right, so now the next trick after that was where I left it up to you. I wanted you to delete the halt here, so let's delete that halt. Yes. And I wanted you to start with 32 and put the word hello in there. Well, I left you some instructions on ASCII values, and it turns out that, well, let me see. Let me call up a Word document, I guess, because I don't have that chart in front of me right now. That's not what I want. I want a new document. There we go. It turns out that 65 is an A, and that 66 is a B, right? So these are the hex values and the letters they represent. Yeah, I want this to all to be no spacing. And 67 is a C. 68 is a D. I want to get up to the H here. 69 is an H, and so on. E, excuse me, and so on. Maybe a better way to do it than a Word document would be a Excel program. That would be a quicker way. So I'm going to start with 65, and then over here I'm going to go equal character, whatever that is, and then you see that A right there. So let's carry this thing down like that. Oops. Let's try that again. And let's copy this and carry it down. There you go, down through S. And then we'll start here with 84 and 85. Copy that. Now you see we're in the small characters. So I'll start over here with 103 and 104. And that's all we need for what we're doing. So here are the numbers we need. It looks like we need a 72 for the capital H. And then we want an E, so that'd be 101. And then two L's, 108, 108, and then an O would be 111. All right, so I've got my numbers here. I'm just going to write those down on a piece of paper. 72, 101, 108, 108, 111. All right, so I've got my numbers ready. So all I have to do now is to figure out how to punch those into these spaces. So let's add a new instruction, and let's poke here this byte with a value of, what was the first one? 72. And I want to put that into memory location 32. And then I want to do a 101 in memory location 33. Well, now, just for fun here, I'm going to go ahead and do an end because I don't want to finish this right now. I want you to finish it. But let's close this. Let's reset everything and make sure it's at the top and run it. Here we go. It's running. And look, there's the H and the E, 48, 65 in hex. And there's the H, E. So we're beginning the word hello. All right, so you see where we're going with this? That's all there is to it. All right, that's about, I'll wrap this thing up here and let you take it from here.